This is the Prequiz number 2. Class. Feel free to work quietly if you don't need help on number 2. But this is a Land Rover being lifted into a tree, and I believe that we're going to say power is work divided by time, right? The power is 1.2 times 745.7, right? And the work is going to be, I think we're lifting this thing, so it's mgh, right? And then we want to know the time, so we're just going to do a little math here. So power, I get 1.2 times 745.7. That's 894.84 Brady watts. Used to be Riley watts, but there it is, right? Okay, and then the work is we're going to lift that thing up into the tree, so it's 1,300 kilograms and 9.81, and the tree is 5.7 meters. So I'm going to store that guy, and then 1,300 times 9.81 times 5.7. That is a lot of work. That's 72,692.1 joules, right? Yeah, go ahead. And then our time is going to be power, or work divided by power, right? So it's going to be 72,692.1 divided by 894.84. So divided by, I have to recall that thing. And I get 81.2 seconds. Is that what it is? Yeah? Oh, all right, thanks. Number 3. I think everybody's clear that it's potential energy, 1F-kx squared is 1F-mv squared, right? But the pitfalls turns into 1F-mv squared. Why is it a massless spring? There is no such thing, but why do they say massless? Because imagine that spring at the moment it fully extends. Isn't the spring also moving? So were it to have mass, it would also have some of the energy that the spring stored, right? Now, think about that problem. The very tip of the spring is moving as fast as the marble. Halfway down, it's moving half as fast. 3/4 of the way out, it's moving 3/4 as fast. How would you calculate the kinetic energy of that spring? It wouldn't just be, we couldn't just take the average. You'd have to do, I don't know, right? It's a calculus problem, right? So that's why we talk about massless springs, because that takes the mass out of them, right? So this is going to be 1/2, 34, and then it's 5.8 centimeters, so 0.058 squared is 1/2, and then this is 0.018. I think that's where we lost you probably if you're not getting the right answer, is that. And then for number 4, let me just draw the picture, and I don't think I need to do any more. But this is going to be possibly one of the world's best pictures ever drawn in a physics classroom. So you guys, can you just prepare yourself for that? Because I want to actually bring you back to Earth after this is over. And I don't want to be like, that's the end of the class. Okay. So the bowling ball starts... The bowling ball. You're supposed to get off the chair when you do that. It starts here. Whoops. It starts here. And it swings there. Whoa. Wow. It starts here at a height of, isn't this height? Here, we need to borrow a little space. Got to borrow this space. It starts here at 0.15 meters. Yeah? And then over here, it's some other height. Yeah? Here it's some height, we don't know. Right? Then I give it a push. I push it some distance. Isn't this 0.35 meters? And I push it with 11 newtons. Yeah? So what do we have here? Yep. And what do we have over there? MGH, right? Is it moving over there? No, it's got to be zero velocity over there because it wouldn't be at its highest point if it was moving, right? It wouldn't be at the top, right? Okay, so it only has mgh over there. Now, is there a force and a distance mentioned? Yeah, so now we got to decide which side is it on. Is it on this side or that side? I think it's on this side because it speeds you up, yeah? Right, so the force times distance is the only one that you can't put before or after or something like that, right? So it speeds you up, so you're going to have mgh plus fs is mgh, right? And it's on the left side, not because it happened before, because it happened sometime in the middle, right? It's there because it sped you up, right? And then here it's mgh. Is that good? Does that help us? Does that help us enough? I'm just trying to see if I still have audio level. Because I'm so Scottish, I'm using the very last little bit of a 9-volt battery. When the battery wears down, that light goes off. And then the videos all look like.
Yeah, some of your videos are like, the audio is weird.
Is it weird?
Yeah. Like on the conservation of energy.
Yeah, because I'm moving around and it'll cut out. And then when people get text messages, you'll hear the right, which is the